Okay, now we're going to implement the reverse method, and before we do that, we're going to write some tests for it. Okay, so test public void test empty reverse. All right, and let's see. Essentially, we start with an empty stack, and when we reverse an empty stack, we should get an empty stack. So really nothing should change. So let's go ahead and call reverse on this and make sure the depth is still 0 and the capacity is still 3. So assert equals 0 stack empty 3 depth, and assert equals 3 stack empty 3 capacity. Okay, and then we'll do a reverse test on ABC. This will probably be the more interesting one. Public void test ABC reverse. Here we'll just do stack ABC6 reverse and assert equals, okay, so this should still have 3 elements in it. And it should still have a capacity of 6. And it should definitely not be the same stack. I guess we can do an assert not equals. Do we have that? No, we didn't save the original stack, so we can't do that. Okay, that's fine. We could do a copy or something clever like that, but I think what I want to do here is I want to just pop the last element off of that stack and check if it's A. So it should no longer be C now, it should be A. So I can do string reverse stack ABC6 pop and check if that is indeed A. Okay, and I think that's good for now. And actually, the way we're going to implement this reverse method as a secondary method, we're going to use clear. So basically, we're going to copy something. We're going to clear the original stack, and then we're going to put the things from one stack to put the elements, move the elements from one stack to another. And when we do that, they should end up in the reverse order. Okay, so anyway, I need a clear, and a clear just gets rid of all the elements in a stack. So public void test empty clear. Okay, so stack empty 3 clear. And for this, I'm basically going to just cut and paste those. Boom. And I think, yep, that looks right. And this next clear test, test A, B, C clear. Okay, for this, I'm going to copy and paste this and modify them. Clear here. And let's see, I want to check that the stack becomes empty, but of course it should have the same capacity. And I think that looks good, so let's run these tests, and we should expect them to fail. All right, because nothing has been implemented, 4 tests caused an error. That's a good sign. So let's go implement clear first. That's the easy one. Actually, I think both these methods are fairly easy to implement. So clear, actually, since we're using a list, we can just clear the list. A list has a clear operation. So the list contents, that'll empty the list. The capacity stays the same. So the size of the list becomes 0. So I think that should work. And let's go ahead and run that. And we see that only 2 tests caused an error. And right, the reverse tests are still not passing. So let's go ahead to reverse. And I think this is going to be an easy implementation as well. So to reverse the stack, I'm going to create a copy of the stack. And that's not going to be a result. That's not going to be something I'm returning. I'm not returning anything from here. We want to reverse the elements in place. So I'm just going to call this copy equals this dot copy. Okay, so I'm copying all the elements into the copy stack. And then I'm going to clear this stack. Okay, so I'm emptying this stack, but all of my elements are in the copy stack. So I'm just going to take these out one at a time. I'm going to pop from the top of this copy and then push into my current stack. So I should have ABC from, I mean, if we think about a concrete example where we have a stack with ABC in it, A's at the bottom, B's in the middle, C's at the top. So if I pop from that and push it into an empty stack, I'm going to pop C, and then C is going to be, and then when I push C into the empty stack, C is going to be at the bottom. Okay, so I pop C from the top, now it's going to be at the bottom of my new stack. I'm going to then pop B and push it. It's going to be in the middle. Then I'm going to pop A, push that. Now that's going to be on the top. So now I just want to iterate through the copy. So E element in the copy. For each element in the copy, no, I don't want to iterate. This is definitely what I don't want to do. I'm sorry about that. If I iterate, I'm going A, B, C. I don't. I want to go from top to bottom, C, B, A. So what I'm going to do here is I'm just going to use a plain old while loop. So I'm going to say while copy depth is not equal to 0, while there's still elements in this stack, I'm going to pop an element from the copy, and I'm going to push it onto this stack, which is empty right now. I mean, which we have cleared. So it's originally empty. So this push e element, and then at the end of this method, this copy stack will have no elements in it, and the original stack will have all the elements in reverse order. And it is a little bit confusing unless you actually draw a picture of this and kind of step through this one statement at a time, and you can see that the elements will become reversed. So I said that, and now let's make sure it's true. Let's run these tests, and everything passes.